Regular self-testing of your chemistry knowledge is crucial to success in your A-level. In this video, I'll be helping you with a retrieval practice technique known as blurting, and how using this can coach you to develop some seriously good thinking skills ahead of your exams as part of your regular revision. Shortly, I'm going to give you a blurting prompt, which will be a single word or sentence related to your chemistry A-level. You then need to set yourself a time limit, and within the time you have, write down as much as possible that you can recall about the topic I've set from all across the A-level. Make sure you practice some good dual coding here and don't limit yourself just to words. Diagrams, reaction equations, anything like that is really useful. Don't use any study resources though, and make sure you don't communicate with anyone else during the time. Quickly check out the video description now for some tips on what you could put down on the page. When your time is up, unpause the video and I'll take you through the themes you could have hit on during your writing to see where your successes and gaps are with the course content. So your blurting prompt for today is catalysts. Pause the video now and don't forget to come back when the time is up. Welcome back. So let's see how you did by going through some catalyst themes from across the A-level. I'm using the OCR-A module layout here because that's the course I teach, but most A-levels cover the same material and I'm sure you'll see lots of stuff you recognise. We're kicking off here with Module 3, which is in the first year of the A-level and part of the AS level content for the A-level as well. Here we've got the clear definition of what a catalyst is, so make sure that we've got here that it increases the rate of reaction and is regenerated or is chemically unchanged. There's loads of flexibility there. And don't forget that the catalyst works by providing an alternative route for reaction that has a lower activation energy than the uncatalyzed route. So there's a double whammy there, the definition and then how it works linked to the definition. We've got the rate of reaction theme here, and you could have the definition of that. And there's also heterogeneous and homogeneous types of catalyst. Make sure that you've got an example of each of them. A heterogeneous example, a really quick go-to for this, is the Haber process. Iron in the Haber process is a solid, and all the other components of the equilibrium are gaseous. For homogeneous, your best bet is to go with an acid catalyst from organic chemistry, like in an esterification. So then we've got the Boltzmann curve. Now this is sometimes called the Maxwell-Boltzmann distribution curve, but the Boltzmann curve effectively has the catalyst indicated on here because it's going to have a shift to the left of that activation energy. So the area under the curve above the new activation energy is greater, meaning that more molecules have energy greater than or equal to the activation energy than before it was implemented. We also have the enthalpy profile diagrams. There's a link at the top of the screen here to loads of videos, but this is a really popular one on my channel, and the enthalpy profile diagram can be adapted for introducing a catalyst just to make that bump at the start, whether it's exo or endothermic, that little bit lower. Equilibrium attainment is mentioned here as well, because whilst the catalyst doesn't affect the position of an equilibrium, it does allow us to attain the equilibrium quicker. So we reach that point of equilibrium quicker because it increases the rates of the forwards and backwards reactions by the same amount. Moving into Module 4, and this is typically where we start to see examples of catalysts. Now we have the obvious ones here. We've got the alkene to alkane reaction, which uses nickel, another example of a heterogeneous catalyst and a transition element catalyst, I might point out. And we've also got alkenes going to and from alcohols, using acid catalysts in either direction. But what people often overlook is that the halogen radical in the two propagation stages of radical substitution also acts as a catalyst. So have a look at those two propagation stages and you'll notice that the halogen radical goes in and comes out chemically unchanged. Moving into Module 5, and we're in the second year of the A-level now, and we've got the rate equation. So we should expect to see a catalyst as one of those concentrations that's either first or second order in the rate equation because we know it affects the rate of reaction. Here we've got lots of mention of the transition elements as well. You need to make sure that you know examples of each of these. Transition elements as catalyst could be iron or nickel, like those we've already mentioned. Transition element ions, well, we've got copper 2 ions can be used as a catalyst in the reaction between zinc and sulfuric acid. And transition element compounds, well, we see those come up quite often in Module 6, such as the halogen carrier catalysts, which are used in the Friedel-Crafts alkylation, Friedel-Crafts acylation. We've got the halogenation of benzene here as well. They all use halogen carrier catalyst of FeCl3. And so watch out for that use of a transition element compound in Module 6. We've also got catalyst in nitration of benzene. Again, this is going to be concentrated sulfuric acid. And don't forget, I've already mentioned it, but we've got the esterification and the hydrolysis reactions that use the acid catalyst in either direction here, also in Module 6. So do you think that's everything, or do you think I've missed something out? Why not leave a comment down below saying which reactions you think I should also include in this, or what areas of the course you think catalysts come up in, or have a look at which ones that you're instantly recalling and which ones you've missed. Which one did you miss out? Let me know in the comments down below. Please leave this video a like before you go, because it really does support my channel, and click the links on screen now to be taken to more chemistry knowledge. Until next time though, happy revising.